Hello friends, last time we discussed about Dobryn's law of triads and Newland's law of octave, and I already told you what the law was and how the law failed to fulfill the conditions, respective conditions. This time we will be talking about Mendeleev's periodic table. It was found by Dmitry Mendeleev in the year 1869, a Russian chemist. A chemist, in early days, someone who learns about chemistry is a chemist. We didn't have the word scientist, we called it as chemist. So he made a chart, a very systematic chart based on the atomic mass of the elements. Let us see what his law was. Mendeleev's periodic law states that the physical and chemical properties of the elements are periodic functions of their atomic mass. That means the properties of the elements are based on periodic functions of their atomic mass. What do I mean by the word periodic here? Periodic means after a certain interval of time. Now when I say certain interval of time, what do I mean? Earlier Newland said that the first and the eighth element will have similar properties. So it was a fixed number. The first and the eighth will resemble or have similar properties. But Mendeleev said this was not so. It is not compulsory that the first and the eighth should have similar properties. Properties will repeat. When you arrange the elements in increasing order of their atomic mass, the properties will repeat. But there is no fixed interval. After certain intervals, he used the word periodicity. That is how the word periodicity came into existence. So, Mendeleev's periodic law states the physical and chemical properties are periodic functions of their atomic mass. He made the chart which we call as Mendeleev's periodic table. Let us understand the table here, the features of the table, main features of Mendeleev's periodic table. So, point number 1. In Mendeleev's periodic table, the elements were arranged as per the increasing order of their atomic mass. So, if you see here, hydrogen, then followed by lithium 6, beryllium 9, 10, 12, 14, 16, 19 and so on. So, he arranged it in the increasing order of their atomic mass. He said, second point to remember, that there are 8 vertical columns called as groups. 1, 2, 3, 4, 5, 6, 7, 8. And regarding this part we will talk about afterwards. There are 8 vertical columns called as groups and 7 horizontal rows called as periods. So you can see here the periods. Period number 1, 2, 3, 4, 5, 6, 7. So there are 8 vertical columns called as groups and 7 horizontal rows called as periods. This was the second thing that we have to remember. Thirdly, he said that the elements belonging to the same group will have similar properties. That means, now if you see this group, they all will have similar property. If you take this group, they will have similar properties. So, 3 features to remember. Point number 1, it was based on atomic mass, increasing order of atomic mass, systematically arranged in the increasing order of atomic mass. Point number 2, that I got to remember, it had 8 vertical columns called as groups and 7 horizontal rows called as periods. Point number 3 that I got to remember is that the elements with similar properties were placed in the same group and elements with dissimilar properties were placed in the different group. This was as far as his features were concerned. Now, having said this, what is the advantage? Of course, the work that Mendeleev did cannot be neglected because it was the first systematic chart which was ever produced based on the atomic mass, and it was working to an extent that total 63 elements were known at that time, and he could arrange all the 63 elements with some here and there, some mistakes here and there, which we will be talking about, but at the same time it had certain advantages too. Let us see the advantages first, then we will talk about the demerits or the disadvantages. Now, talking about the advantages or the demerits, here, first thing that I got to remember is that he did not have the Mendeleev periodic table, though it succeeded in classifying all the known elements at that time, it was also to protect. Now, let us see, he succeeded in classifying all the elements. There were certain gaps that he kept. 1, 2, 3, 4. You can see these gaps. These elements were not discovered. But Mendeleev was very sure that there are elements here that is still there in nature and is not discovered. So his prediction was perfectly correct. He named those elements. Okay, he named those elements as what you call Eka boron, Eka aluminum, and Eka silicon. Now, Eka boron, when I say, later we came to know that Eka boron that he is talking about is scandium. Okay, and same way, eka aluminum that he was talking about was gallium, and the third thing, eka silicon that he was talking about was germanium. So eka word is, the word actually means similar. So there is an element which has got similar properties, that of boron, that of aluminum, and that of silicon, and those elements were later found to be scandium, gallium, and germanium. Now, secondly, earlier during his days, noble gases were not known. What was surprising is that in spite of the fact that he made this chart without the noble gas, we were able to arrange the noble gas here in this column, and later it was termed as the zero group. So this became the zero group here. Now this is something surprising here, if you see. One, because the elements are not even known and he could actually classify those elements, we did not disturb the chart and we could easily place it. So it came automatically in an order itself. 1, 4, 6, it is here. Then later if you see 19, 20, 23. So the elements, though these elements were not known, later when we arranged the table, we were able to finally, after Mendeleev had left this world, we could arrange this column here and it was found to be perfect. So two main things that I got to know about Mendeleev's periodic table is this arrangement of elements, prediction of the elements, which I can call. He could predict the elements, that these elements are there in nature. It has yet to be discovered, he was very sure of it. And second thing that was interesting was this rare gases, which did not take a separate table. Now imagine the number 4 was discovered later, but 4 did not come here. It could automatically adjust after 1, 4, 6 like that. So that's an interesting part. Having said this, though Mendeleev's periodic table was more or less perfect, there were many problems with the chart too. Let us understand the chart and the problems here, which we will talk about demerits of Mendeleev's periodic table. Now what was the demerit of the table? That is the disadvantage of the table. Point number 1, if you see hydrogen here, hydrogen is placed in position 1. Though hydrogen is placed in the group 1, but hydrogen has got the properties of fluorine, chlorine, bromine and iodine also. So it could have come in this halogen group also, but it was placed in alkali group. There was no particular reason why hydrogen was kept in alkali group and why not in halogen, because as per the valency, it can come in halogens too. So there was no particular reason which Mendeleev could support. Secondly, classification of isotopes. So now what are isotopes? Isotopes are those elements which have got same atomic number but different atomic mass. Now for example, chlorine has got an isotope, hydrogen has got an isotope, oxygen has got an isotope. So these elements have got, there are certain elements. The chlorine, if you see, there are two chlorines, one which has got atomic mass 35.5 and 37.5, but the atomic number remains the same. So atomic number remains the same, but still atomic mass varies. Now if you see, chlorine has got only one position. Where is the isotope of chlorine? So we did not have the isotope 37. One more chlorine, that is 37. It should have got 37. But the 37 chlorine is not there. Atomic mass 37 is not there. Same way with hydrogen. Hydrogen has got hydrogen, deuterium, tritium. So depending on the atomic mass, the name of the hydrogen also changes. But that position for hydrogen is only one. The other two atomic mass numbers of hydrogen is not there. So you can see hydrogen, though in spite of the fact there are isotopes of hydrogen, there are isotopes of chlorine, those isotopes did not have particular place in the table. Now having said this, there are certain elements which were not adjusted as per the increasing order of atomic mass. Let us see here, cobalt and nickel. Now if you see cobalt, it is 58.9, and if you see nickel, it is 58.7. Now actually 58.7 should have come here and 58.9 should have come here, but it was not so. But here you can see that there are certain elements. For example, let us take it like this. 128 tellurium is here, iodine is here. So iodine should have come here and tellurium should have come here, because it is an increasing order. So 127 should come here, 128 should come here, but it was not arranged as per the atomic mass, increasing order of the atomic mass. So that was one more fault. And now talking about properties of the elements also. If you see fluorine, chlorine, bromine, manganese also comes in this group. Manganese is not similar to, does not have the similar properties as fluorine, chlorine and bromine. Manganese was placed here, it's an odd man out here. Manganese doesn't fulfill the condition of halogens or the properties of halogens. So manganese was placed in the wrong group. So there were certain elements which were placed in the wrong group. So having said this, these were the demerits of Mendeleev's periodic table. Now let us see the whole thing once again. Point number 1. Mendeleev's periodic law states that the elements or the properties of elements are the periodic functions of their atomic mass. That means elements show the properties after certain interval of time, unlike what Newland said. So Mendeleev's periodic law states that properties of the elements, physical and chemical properties of the elements, are periodic functions of their atomic mass. That's the law. Secondly, his table, features of his table. There were 8 vertical columns called as groups, 7 horizontal rows called as periods. Elements having same properties, he said, are placed in same group. Elements with dissimilar properties were placed in different groups. So that were the features. Talking about the advantages. As I told you, it was the first systematically arranged chart as per the atomic mass, and it could arrange all the 63 elements known at that time. Point number 1. Point number 2, he could predict the elements here, which I already told you. He could predict the elements, which element will come here, which elements will come here, which element. Though he did not know the element, though at that time the elements were not even known, he could predict those elements. Of the 3 examples that we already mentioned is Eka boron, Eka silicon, Eka aluminium. Eka boron is nothing but scandium, Eka aluminium is nothing but gallium, and Eka silicon is nothing but germanium. Eka means similar to silicon. So there is an element which is similar to silicon, but it is not yet discovered. There is an element which is similar to aluminium, but it is not yet discovered. So these are the advantages. And secondly, he could, if you see the halogens, the rare gases here, the noble gases here, it was not even known to him, but yet after his chart was made, we could arrange those rare gases without disturbing the chart. So this was the advantage. And talking about now the demerits. First I told you that hydrogen has got the property of alkali groups as well as halogens. Then why is hydrogen placed here? Question number 1. That was the argument. Second was classification of isotopes. Isotopes, chlorine, I already told you it has 35.5 and 37. But chlorine, 2 types of chlorine are there, 2 atomic mass numbers. So if it is arranged in increasing order of atomic mass, then why only 1 chlorine is placed here? Why only 1 hydrogen is there? Though we have got hydrogen, deuterium, tritium, all having atomic mass 1. Next, that we have got to remember, there were certain elements which were wrongly arranged. Here I gave you an example, cobalt 58.9 and nickel 58.7. This should have come here and this should have come here. Same with tellurium 128 and iodine 127. This 127 should have come here and 128 should have come here. So that's again a drawback, because this is based on increasing order of atomic mass. So this is not an increasing order. Here also this is not an increasing order. So there were certain places where increasing order was not properly maintained. Next is wrong arrangement of elements. I already told you properties and groups. Now I already gave you the example here, manganese. Manganese does not belong to this category of elements, that is the halogens. So if manganese does not belong here, then why manganese is placed here? So there were certain elements which were not properly arranged. Now I forgot to tell you one thing. Beryllium, earlier it was thought that the atomic mass of beryllium is around 14.09. That's an advantage here which Mendeleev had, and that I should tell you. Earlier it was thought that beryllium's atomic mass was 14.09. But later, when he arranged beryllium here, after 14, he found that beryllium does not belong here. It comes here. And therefore he could correct the atomic mass of beryllium. That was an advantage, which I forgot to tell you in the advantage. But, so in short, Mendeleev tried his best to arrange the elements in increasing order, and this was more or less perfect because he could arrange all the 63 elements. Thank you.